Good morning. Free body diagrams, which are also called force diagrams, are ubiquitous in physics. Today we are going to go through my 5 steps to solve any free body diagram problem.
Flippin' physics.
Step 1. Draw the free body diagram. As an example, let's look at the standard father dragging his child on a sled problem. Here I am dragging my daughter Genevieve on a sled. The forces in the free body diagram are the force of tension in the direction of the rope, the force of gravity down, the force normal pushes up and is perpendicular to the ground, and the force of kinetic friction is parallel to the ground, opposes motion, and is therefore to the left.
I feel like there should be snow on the ground.
Yeah, it seems like there should be.
Step 2 is to break forces into components.
That box he drew for the free body diagram, is that supposed to be his daughter?
Yeah, the square represents Genevieve.
In this example, the force of tension is the only force we need to break into components, and we can use trigonometric functions to do that. The sine of theta equals opposite over hypotenuse, or the force of tension in the y direction divided by the force of tension. Therefore, the force of tension in the y direction equals the force of tension times the sine of theta. The cosine of theta equals adjacent over hypotenuse, or the force of tension in the x direction divided by the force of tension. Therefore, the force of tension in the x direction equals the force of tension times the cosine of theta. Step 3 is to redraw the free body diagram. Notice, we still have the force of kinetic friction, the force normal, and the force of gravity. But instead of having the force of tension, we now have its components. The force of tension in the y direction and the force of tension in the x direction.
Redrawing the free body diagram seems like a waste of time. Don't we already have all that information?
Bo, that is a typical student perspective. However, I will tell you from a teacher perspective that students who skip redrawing the free body diagram are more likely to make simple mistakes. Step 4 is to use Newton's second law and sum the forces. Bo, could you please sum the forces in the y direction?
The net force in the y direction equals the force normal plus the force of tension in the y direction minus the force of gravity because it's down.
Which then equals mass times acceleration in the y direction.
Bo, do you see how easy that was because we redrew the free body diagram? Step 5 is to sum the forces again in a direction perpendicular to the one in step number 4. Billy, could you please sum the forces in the x direction?
The net force in the x direction equals the force of tension in the x direction minus the force of kinetic friction, which then equals mass times acceleration in the x direction.
Correct. If we were solving a problem, we could now combine the equations we got during steps 4 and 5. Now, let's walk through those steps again. Class, what is step 1?
Draw the free body diagram.
Step 2?
Break forces into components.
Step 3?
Redraw the free body diagram.
Step 4?
Sum the forces.
And step 5?
Sum the forces. Again.
Right. Sum the forces in a direction perpendicular to the direction you used in step number 4. And those 5 steps will help you to solve any problem that includes a free body diagram. Thank you very much for learning with me today. I enjoyed learning with you. There we go. That works. You gotta